Hello everyone, RD here. So we are going to solve this practice problem 4.3 from William Hayt book, Engineering Circuit Analysis. For the circuit of the figure 4.8, determine the nodal voltage V1 if A is, the first one will be 2I1, and then for B, that will be 2V1. Okay, let's write this down. So this will be 2I1. So for this problem A, we will go by this value, right? And now I will assume the direction of the current. So for this branch, I will just follow this 5 ampere current source. So going up. And for this one, I just follow this I1. So going down, going down. And then for this one, I will going to the right. And this one, I will just follow that dependent current source. So going up. And this one, I will just assume this is going down. Now we have the reference voltage here. So let's put our ground symbol here. And the voltage in this node here in the ground will be 0. Okay. I think that's okay for now. And what we need to do is we need to find out the voltage at V1 and V2. Okay, this is 2I1. Okay, let's do KCL at V1. Right, KCL at V1. KCL said that the sum of the currents that going in will equal to the sum of the currents that going out. This is current that going in, all the other currents is going out. So I will have 5 here on the left hand side, and that will equal to, for this I1, I will have V1 minus V2, right, divided by the resistance between them. So the resistance between them will be 1 ohm, okay, and then this current here is going out, so I'll have plus this V1, and the node here is connected to the ground, so this node will be 0. So I'll have minus 0, and divided by the resistance between them, that will be 2 ohm, right? Okay, I want to get rid of the denominator, so multiply both sides by 2, and I will have 10 that equal to 2V1 minus 2V2 plus, and this one will be V1. Okay. So now let's just solve this. So I'll have 3V1 minus 2V2 that equal to 10. Okay, let's just save this as equation number 1. So now we need to do another KCL. But for now we will do at node V2. Okay, KCL at node V2. This current here is going in. This current here also going in. So this current will be V1 minus V2 divided by 1 plus this current here, which equal to 2I1. Let's write that. And then that will equal to the currents that going out here. That will be equal to V2 minus this node here will be 0 divided by 2. Okay. But let's rewrite this again. So I'll have V1 minus V2 plus 2I1. But I1 is just V1 minus V2 divided by 1, right? So I will have V1 minus V2. Okay. And that will equal to V2 over 2. Okay, this one will be V1 plus 2V1. That will be 3V1. and then minus v2 minus 2v2. So I'll have minus 3v2, and that will equal to v2 over 2. And maybe I will just go in there. Okay, we can multiply both sides by 2. So I'll have 6v1 minus 6v2, and that will equal to v2. Or I can do 6v1 minus 7v2 is equal to 0. Let's save this as equation number 2. So I will have this two equation with two variables, and I think I can solve that, right? Okay, so now I will just rewrite equation number 2 equation number 1, because we are asked to find v1. Yeah, I think we can just eliminate that v2. So in order to eliminate that 7, I need to multiply equation number 1 by 7. So I will have 21 v1 minus 14 v2, that will equal to 70. And for equation number 2, I multiply this by 2. So I will have 12 v1 minus 14 v2, and that will equal to 0. So now let's subtract this equation. This minus 14 plus 14 will cancel each other. So I can just get this one, which is 9v1 is equal to 70. So I will have that v1 will be 70 divided by 9, and the unit is volt. Okay, so this is for the answer for the point A, right? The point A. Okay, and I think our answer is correct. We did not make any mistakes in this calculation. But for B, we need to change this into what? Into 2v1. Okay, let's change this into 2v1. We can still use this equation number 1 because it does not change, right? And we need to do KCL at v2 again, but this time with this 2v1 value. So I'll have KCL at node v2. KCL at node v2. Again, this current here is going in. This current here is also going in. This current here is I1, and this current here is 2v1. So for this current, I will have v1 minus v2 divided by 2. For this current, I will have 2v1. And that will equal to this current that going out, which is v2 minus 0 divided by 2. I think, oh, this is 1, right? This is not 2, divided by 1, sorry. Yeah, okay. I think we can just directly multiply both sides by 2. So I will have this one will be 2v1 minus 2v2 plus 4v1, and then that will equal to v2. Okay, so I'll have 6v1 minus 3v2 is equal to 0. Yeah, because all is moved to the left hand side, right? Or I can simplify this as what? 3v1 minus, oh no, I divide both sides by 3. So I will have 2v1 minus v2, that will equal to 0. Okay, so now I can just get that V1, V2, sorry, not V1. V2 is equal to 2V1, right? Let's make this as equation number 3. So we can substitute equation number 3 into equation number 1. Okay. So we will have what? We'll have 3V1 minus 2V2, but V2 is 2V1. And that will equal to 10, right? So I will have 3V1 minus 4V1 will equal to 10, or minus V1 will equal to 10, and then V1 will be minus 10, and the unit is volt. Yeah, and is it right? Yeah, the answer is the same as the answer key, so I think I did not make any mistake in the calculation. Okay, thank you for watching, and bye bye. Do not forget to like and subscribe to my channel. Thank you.